Welcome to Math 1314. This is section 2.1 and a little portion of 2.3. All right, in this very first question, they're going to give us some points and they're going to ask us to plot them on a XY coordinate system. Well, what does that look like? Well, it looks like the picture here. We have a x-axis, which is a number line. Positive numbers are on the right, negative numbers are on the left. We have a y-axis that goes up and down. Positive numbers up, negative numbers down. The dot right in the middle where the two axes intersect is called the origin, and it looks like 0, 0. So all points that live here in the XY coordinate system, which is called a rectangular coordinate system, is measured in the terms of x comma y. The first number tells you how far to go left and right, and the second number tells you how far to go up and down. So let's look at a few of these points. Let's see. We have A, which is -2, -4. All right, so we go -2 to the left and down -4. 7/3 and 5/4. Well, I don't know how big that is. Let's see. 7/3, 3 goes into 7 2 times, so 2 1/3, so about 2.3. All right, so 1, 2, and a little bit. All right, 5/4 is 1 1/4, so here's 1 and a little bit up, and so this is 7/3 and 5/4. Now, in Connect Math, close is good enough, so as long as you're reasonably close, it should accept the answer. Let's see, C, -2.1. All right, 2.1. Again, that's just a little past 2 and up 3.4. So around that area, maybe mine is a little high, looks like a little bit past 3.5. But maybe it would take it. D, let's see, D is 3 -pi. Let's see, go over 3 and -pi. Let's see, pi is about 3.14 and it's a negative, so down there. 0 and 4.3. All right, 0 and up 4.3. Let's see, square root of 7, 0. Well, I don't know what the square root of 7 is, so I got my calculator out and calculated it as 2.64. All right, so 2.64, a little bit bigger than 2.5 and 0. So it's sitting on the x-axis. All right, let's see. In question 2, they're going to give me 2 points, -5, 1, and 1 -3. And they want us to find the distance between them. So here's a rough sketch. I have 2 points, x1, y1. There's my first point. Here's my second point, x2, y2. So 2 points, and I want to figure out how far is it between them, this distance d. Well, if you remember from geometry somewhere, we have something called the Pythagorean theorem for right triangles. And that is, if you take a squared plus b squared, it's the length of the hypotenuse squared. Well, we can use that here because if you look at this little picture, which I'll complete now, there's a little right triangle in there, so I do have a distance here and there. So the distance is the square root of two things squared, just like the Pythagorean theorem. So I need to figure out how far it is on the x, and that's x1 minus x2 squared, plus how far on the y, y1 minus y2 squared. Now it doesn't matter if I wrote this as x2 minus x1 and y2 minus y1. However you put the order of the x's won't matter because you're squaring it and they're going to be positive anyway. Alright, so I'm plugging in my points. My x values are minus 5 and 1. Y values are 1 and minus 3. Alright, so let's see what happens. Minus 5 minus 1 is a minus 6 squared. Alright. 1 minus a minus 3 is 1 plus 3, which is 4. And 4 squared is 16. And so add these two together and you get the square root of 52. Now I can't simplify that. A 4 won't go in there. Well, let's see, does 4 go in there? 4 goes into there once, so 13 times, I guess. So this is the square root of 4 times 13. Yep, that is true. And so this would be square root of 4, square root of 13. Do I have room to put this somewhere? I guess so. This is 2 square root of 13. All right, what about the midpoint? Now looking at this, we have, and let me fix this up now that we did simplify that, as 2 square root of 13. And again, this was representable as 4 times 13. Alright, the midpoint. If I have 2 points again, and I want to figure out where is the point in the middle, the place that's halfway in between them. Well, the formula is pretty easy. You simply average the x's and you average the y's. Why do I say average? Well, because we're just adding up two numbers and dividing by 2. So minus 5 plus 1 is minus 4. Minus 4 over 2 is minus 2. And 1 plus a minus 3 is a minus 2. Minus 2 over 2 is minus 1. So that's the actual coordinates of the point that is halfway in between the 2 points that they gave us. Alright, in question 3, we want to figure out if these points actually satisfy this equation or not. Let's see. 2, 5. So x is 2, y is 5. 2 squared plus 5. Well, that's 4 plus 5, which is 9. Yes, that's true. What about the point 6, 8? Let's see. 6 squared plus 8. Well, 6 squared is 36. 36 plus 8, there's no way it's going to be 9. So no on that one. And what about the last one here? 1/3 and 80 over 9. Well, let's see. 1/3 squared. That's a third times a third, so 1/9 plus 80 over 9. That would be 81 over 9, and 81 over 9 does reduce to 9. So yes, it does live on that particular item. All right, in question 4, they're giving me a graph and they want us to figure out, is this the graph of a function or not? Well, a function only takes one input and produces one output. So we do something called the vertical line test. All right, so I make all these vertical lines. Notice each vertical line only intersects the graph in one place. So yes, this is a function. In question 5. In question 5, we try the vertical line test. I mean, over here, yes, it would only touch in one place, but along here it touches more than once, and so therefore this item we're looking at is not a function. So does not define y as a function. Question 6. Question 6, they're going to give us a function in this definition, and they're going to ask us to calculate a bunch of outputs. So when I look at this function, what I really see is f of blank is 5 times blank squared minus 3 times whatever's in the blank. So whatever input goes in here, I'm going to place it in those two places and then calculate the output. So minus 3. Minus 3 squared is 9. 5 and 9 is 45. I've got a minus 3 times a minus 3. That's a plus 9. 45 and 9 is 54. So input of minus 3 and the output is 54. All right, question 2. F of minus 2. All right, so minus 2 squared is 4. 5 times 4 is 20. I've got a minus 3 times a minus 2, so a positive 6. 20 and 6 is 26. Minus 1. Minus 1 squared is 1. Minus 3 times minus 1 is a plus 3. And so 5 and 3 is 8. Part 4 here. 0. Oh, that's the easiest. Plug in 0. 0 squared is 0. 3 times 0 is 0. 0 minus 0 is 0. And the last one here, let's see. F of 1. All right, 1 squared is 1 times 5 is 5. Minus 3 times 1 is 3, and 5 minus 3 is 2. So, had some inputs, calculated, and figured out the outputs. Question 7 gets a little harder because here's my function. H of x is x squared plus 5x. So whatever my input is, it's going to go in there, and in there. They asked us to figure out h of p minus 3. Okay, so I'm just going to fill that into the blank. That's the easy part. Now the harder part is I need to grind all this out to figure out what comes out. Well, let's do the easy part first. 5 times this piece, so 5p minus 15. Now this piece that's being squared, I wish it were true I could just square each piece, but that just is not true. I actually have to write this out and now go term by term. P times p, p times minus 3, minus 3 times p, minus 3 times minus 3. And when we do that and combine like terms, I get p squared minus 6p plus 9. Okay, and so what? Anything combined here? Let's see, p squared, yep, minus 6p and a 5p. That's a minus 1p. And 9 minus 15 is minus 6. So the way to prevent getting lost is replace the x with a blank and then you'll know exactly how to fill in whatever input they ask you to figure out. All right. Question 8. They are giving me a function in terms of some points. Well, what do these points mean? Well, the first number is the input and the second number is the output. So what this is telling me for this first point, minus 2, 5, is minus 2 produces an output of 5. Minus 5 produces an output of 2, 5 produces 6, and 4 produces 9. Alright, so what do they want? They want f of minus 5. So, minus 5 is the input. What does it produce? Let's see, minus 5 produced a 2. That was this one right there. Alright, question 9. Question 9, they're going to give us a graph. And many students have problems understanding what the graph is telling them. So before we look at the complicated one there, let's look over here. I have my x and y axes. The blue line is my function. When I look at the points along the graph, they are not the output. The points that live on the graph are a combination of input and output. So if I take this input, the output actually lives there on the y-axis. So in this question, question 9, they're asking us two things. From the graph, what is the domain and what is the range? So what do these strange words mean? Well, the domain is the collection of inputs. What x's along here, along the x-axis, are being used as an input? And then the range is, well, what comes out? So the important thing you have to ask yourself is, let's do the range first. How low does this graph ever go? Well, let's see. The lowest it ever gets seems to be here at a lowest of 1. Okay, so there's the lowest. The range goes from minus 1. And if I look on this side over here, the graph keeps going up forever. And therefore my range is on the y-axis, and it's from minus 1 to infinity. Minus 1, let's see. Yes, we did get there. The lowest was positive 1, sorry. All right, what about the domain? The domain is how far left and right. Let's see, any of these numbers have an output? How do I know? Well, there's no graph there. So these numbers don't produce any output. The first appearance of something is here at minus 1, and it produces this open dot. This next one produces this, so all of this is producing a point on the graph. And so where are the inputs? Well, they start at minus 1, but they don't include it, and they go off to the right hand side forever. Okay, so domain is about the left and the right. The range is about how low and how high. All right, in question 10 here, they're asking us for these functions to figure out what's the domain. What inputs can we use? Well, let's see. I see this problem has a x, or a variable, in the bottom part, in the denominator. And if I remember, let's see, 0 divided by 5 is 0. But if I flipped it around the other way, 5 divided by 0 is undefined. Now, anything important about 5? No. I'm just trying to make the point that whenever you have a 0 in the denominator, it's undefined. So in this problem, I don't want the bottom to be 0. Well, let's see, when would that happen? X minus 49 is 0. If I solve that, I get x is 49. So if I used the input of 49, my function would be undefined. Therefore, I need to remove that point. Now, that's the only number that makes the bottom 0, so everything else works. So I get the left part, which is minus infinity to 49. It's an open dot, so I get a parenthesis. Infinities always get parentheses. And then the right part starts not at 49, but right above it and continues to the right forever. All right, well, what about G? How is G any different? Well, some of it's still the same. And that is, I don't want the bottom to be 0. But I think this does factor into a product as the difference of two squares, x minus 7, x plus 7. So if I set each one to 0, that would say 7 and negative 7. So I don't want those values as an input, because if I used them, I would make a 0 in the denominator, which would make the whole function undefined. So on my number line, that's removed, but everything else is okay. There's a left part, a middle part, and a right part. The left, minus infinity to minus 7, parenthesis, because it's an open dot. I got the middle stuff, which is minus 7 to 7. And then I have the stuff on the right, which is 7 to infinity. And I've got these U's for unions to glue it all together. And that's my domain. And finally, what about our last function, h of x, which looks very similar. The only difference is, notice there's a plus down there. Previous problem we had a minus, which gave us minus 7 and 7. What about this one? Can this ever calculate to be 0? I don't know, let's see. What if I picked 7? 7 squared plus 49. No, that's 49 plus 49. That's not 0. I know, minus 7 works. Minus 7 squared is 49 plus 49. No, that's not 0 too. What's going on? Well, if I move the 49 to the right, that would say x squared is minus 49, or x is plus or minus 7i. So the only numbers that make it 0 are complex. So there's nothing to remove from my number line. And if there's nothing to remove, then the domain is everything. All right, so 3 very similar but yet different problems where we had a plus, a minus, and the first one did not have a square. And in our last question, we're looking at what about square roots, and again finding the domain. What inputs can we use? Well, let's remember a few things first. Square root of 4 is 2. That's nice. Square root of 0 is 0. Okay, that's fine too. But the square root of minus 4 is 2i. That's a complex number. I don't want that. What I want is I'd like to have a real number to come out as an output. So that means I need the inside part to calculate to be positive or 0. Because if that happens, then the square root of that is a real number. So what do I need? I need the inside part to be greater than or equal to 0. And this was always going to be true in terms of square roots. So if I move the t, moving the t is not going to flip the sign. That says all the numbers 36 is greater than or equal to those numbers. So that's a closed dot at 36. Which way do I shade? Pick a test value like 35, and 36 is greater than or equal to 35. So I can use 36 and everything under it. Okay, well, what about the second one here? How is it different? It looks like it's just turned around a little bit. But I still need the stuff under the radical to be greater than or equal to 0. So pick all the numbers greater than or equal to 36. See, closed dot, everything to the right forever. So we have a bracket 36 to infinity. And what about the last one here? Let's see. Well, normally I would see this thing under a square root, and I would say 36 minus t greater than or equal to 0. But this thing is also in the denominator, which means I don't want this denominator to be 0, because square root of 0 is 0 and 1 over 0 is undefined. So I can't allow it to be 0, but it's still greater than. So 36 bigger than t, so that's everything under 36, got an open dot, which gives me the parenthesis on the 36. Good luck, and if you have any questions, post them to the discussion board.